How long would you survive inside a black hole? Spoiler, stellar mass 1, about 0.09 seconds. On a supermassive one, hours. And on one specific type, potentially forever. 6 classes, ranked by lethality. One technically lets you live forever. We'll get there. First, the rules. This only works if we're honest. Here's the deal. Next 12 minutes, 6 classes of black hole, blunt breakdown, no filler. You wear regular clothes. No spacesuit, no ship, no shielding, no rescue. Just physics. The clock starts when your feet cross the horizon, and stops when you stop being a person. That's the metric. Seconds from the horizon to death. And before anyone comments, yes, spaghettification. Gravity pulls your feet harder than your head. You stretch into atoms. That's it. That's the word. We'll use it a lot. We start with the ones that shred you instantly. Stellar mass black holes, the most common kind. 3 to 20 times the sun's mass packed into a small town. These are what massive stars leave behind when they run out of fuel and collapse under their own weight. The core caves in, outer layers blow off as a supernova, leaving a gravity well a few kilometers wide. Here's why they kill fast. Horizon is small, so the gravitational gradient across your body becomes enormous. We're talking tens of thousands of Earth gravities of stretching force across a 2-meter body. Basically, catastrophic. Before you even reach the horizon, you're not a person. You're a thread. Bones separated, blood stops flowing. Your atoms get pulled into a single line. That's stellar mass. 0.09 of a second, and done. Total survival time? Roughly 0.09 seconds from the moment tidal forces exceed what your body handles. You don't feel most of it, because your nervous system also stops being a nervous system almost instantly. You're pasta before you're a corpse. Cause of death? Geometry. The black hole doesn't hate you. It's just too small to be gentle. And here's the strange part. Bigger black holes are gentler. Which sounds wrong. Bigger should mean worse. It doesn't. Let me bluntly show you exactly why that is. Intermediate mass black holes. 100 to 100,000 solar masses. The awkward middle child of the family. For decades, astronomers barely had any confirmed examples. We knew stellar mass and supermassive ones existed, obviously, but the ones in between were basically ghosts. In the last few years, we've spotted decent candidates, mostly hiding inside dense star clusters or dwarf galaxies. So why are these bigger black holes gentler? Event horizon scales with mass, but tidal force at the horizon actually decreases as the hole gets bigger. Basically, a bigger horizon spreads curvature over more space, so the stretch across your body is less brutal. On an intermediate black hole of, say, 1,000 solar masses, you might stay intact for several seconds. After crossing the horizon, you'd still be crushed and stretched, just not instantly. You'd notice things went wrong. Time to look around. Time to regret every single life choice that led you straight here, catastrophically. Death is still guaranteed. The singularity doesn't care about your feelings. But you get seconds, not milliseconds. 5 to 15 seconds of consciousness, depending on mass. Scale up again and you cross the horizon alive. Supermassive black holes. This is where it gets weird. These monsters sit at the centers of galaxies. They range from millions to billions of solar masses. Our galaxy has one, Sagittarius A star, about 4 million solar masses. M87 has one at 6.5 billion solar masses. Modest, cosmically speaking. TON 618 is a beast, 40 billion solar masses. Its horizon dwarfs our entire solar system. Here's the counterintuitive part. On a supermassive black hole, tidal force at the horizon is basically nothing. You wouldn't feel it. No stretching, no crushing, no warning. You cross the point of no return unnoticed. No signal, no flash, no visible boundary. 1 second you're outside, next you're inside, your body unchanged. You could look around. The sky behind you distorts, squeezed into a shrinking disk of light. The stars smear. You're still breathing, still conscious, basically fine for now. How long do you have? Depends on the black hole. For Sagittarius A star, roughly 20 seconds of comfortable fall before tidal forces begin to actually hurt. Total time from horizon to singularity, about a minute. For M87, more like half an hour. It dumps Hawking radiation into your body as it goes. Quick version. Black holes are not perfectly black. They leak energy slowly through a quantum effect right at the horizon. For big black holes, this is negligible. For tiny ones, it's fast. A mountain mass primordial black hole is evaporating right now, bleeding energy into space. By the end of its life, it releases the energy of a nuclear bomb in its final second. So survival time is basically not defined. You don't fall in. You get shot through by concentrated gravity. Death by drive-by, essentially. Milliseconds if it hits you, completely unaffected if it misses. That's primordial black holes. Primordial black holes aren't confirmed. But if dark matter includes them, one might be crossing the solar system right now. Probably not. Almost certainly not. But the math allows it. One class of black hole breaks the rules entirely. Extremal black holes. This is the payoff. 2 flavors. Extremal Kerr, spinning as fast as physics allows, and extremal Reisner-Nordstrom, carrying the max possible electric charge. In both, the black hole is tuned to a mathematical limit. The inner and outer horizons merge into one surface. Why does this matter? Because the geometry inside changes completely. The infinite tidal forces at the center get pushed away. Stable orbits become possible inside the horizon itself. In theory, you could enter an extremal black hole and just orbit. Indefinitely. Never hit a singularity. Never get crushed. Never get shredded. This is the longest survival time on the entire menu. Effectively, forever. In the idealized case, you'd need food, air, and a reason to live inside a black hole, but the geometry itself doesn't kill you. Here's the catch. Extremal black holes are almost certainly impossible to make. You can't spin a real black hole all the way to the extremal limit. Nature keeps stopping you short. You can't pile enough charge on one without the charges repelling and leaving. Extremal solutions are physically forbidden. Exactly what you'd expect from the one loophole that lets you live. Physics giveth, and physics taketh away. So what does any of this mean for us? Down here, on Earth, chewing on this in an armchair, the nearest known black hole is roughly 1,500 light-years away, Gaia BH1, a stellar mass hole. It's in a wide orbit with a normal star. It cannot reach us. It isn't moving toward us. It's a rock in a very slow river, a long way from your kitchen. Basically, not your problem. Sagittarius A star, at our galaxy's center, is not going to eat the galaxy. Here's the thing. Supermassive black holes are relatively small compared to the galaxies they anchor. They pull on stuff near the center. Our Sun orbits Sagittarius A star at 26,000 light-years, stable for as long as the Sun burns. Black holes are not villains. They're engines. They regulate star formation in galactic centers and seed galaxy growth. When they collide, they ring space-time like a bell. We've heard those bells ring on gravitational wave detectors dozens of times. They're the loudest events in the universe by energy output, and they happen constantly. Your survival time inside each one is basically a way of measuring how weird gravity gets when compressed. Stellar mass? Microseconds and a shredded corpse. Intermediate? Seconds. Supermassive? Minutes to hours. Kerr? Undefined. Basically nonsense. Primordial? Not applicable. Extremal? Potentially forever, if the universe actually let them exist. Which, spoiler, it doesn't. The takeaway isn't fear. It's that gravity, cranked to its extreme, does things to space and time. Our intuition was never built for it. A black hole is what happens when mass wins the argument. One last loose thread before we close. The forever black hole from the intro was the extremal one. Yes, it's cheating. Yes, it probably can't exist. That's basically why it lets you live at all. Because the universe isn't allowed to build it. Extremal is essentially a math limit, not a real place. I bluntly explain space every week. No fluff, no pretending it's simple when it isn't. Hit subscribe. Want to know what happens when you get too close to a neutron star? Somehow worse. Watch that next.